Hello everyone and welcome back to a new session, Computer Science 2, MCS 2514, Lawrence Technological University for the summer semester of 2022. We're gonna continue with where we left off. We already did chapter 1, chapter 2. Right now we're gonna do chapter 3, chapter 4, and this would be part 2 of week 1A. Also, I'm gonna assign homework 1 and project 1, which is gonna be due, or the homework is due Sunday and the project is due the following Sunday, which is 2 weeks from now. So chapter 3, expressions and integrity, chapter 4, making decisions. I have my book as usual in front of me and I'm gonna go by the book. I have Visual Studio open as well with a basic simple program, empty program. So chapter 3, expressions and integrity. Topic 3.1, the CN object. What is the CN object? CN object can be used to read data type at the keyboard. It's a object provided by this library, input and output stream, that allows me to read characters or a stream of data into my program from the screen or from the user into the data. A simple example would be see out some question to the user. What is the length? What is your height, for example? Then I'm gonna CN into some variable height. You're gonna start noticing, by the way the style of my typing. I append L to any local variables. Any variables within this scope, I'm gonna append it with L. This indicates to me, it's a good habit to have for you as well. This indicates to me that this variable is only local to this method. So height, I'm gonna just use int for now instead of float. L height. So I declared my variable. I didn't assign it any value. That means it has default value. Default value for an int is a garbage value. I'm gonna show you in a second. Then I'm asking on the screen, what is your height? Notice from literal, this is how I remembered as a student, the direction of the arrows. From the literal to the cout means from my program to the screen. CN arrow into variable, that means it's from the screen into my variable. Because sometimes you have an exam on a piece of paper with a pen, you don't have a PC in an interview, whatever the settings of that interview, and they ask you to write a program. So it's a good habit to follow, just so you remember. Cout is not into the variable. Cout out of the variable. So now that I did these 2 lines, I'm gonna say, okay, just display it. Let me see what I typed. Now I'm gonna run. Let me break point here. I'm gonna show you the default value of an int, which is garbage. If I hover my mouse, I'm assuming at this point, you know, as a prerequisite for this course, you know how to run a software through Visual Studio and how to use a breakpoint and how to step through your code. If you don't know, let me know, whether by email or through Canvas, that you don't know, and I'm gonna help you improve the skill. If I hover my mouse at height, notice the trash, the garbage value for an int. Now I'm gonna step over with F10, or I can step over with this icon. So cout, what is your height? Now that I stepped over, notice this is the screen. CN F10. Now the screen is waiting. What is my height? 6. Enter. Now that I hit enter, it proceeded to the next statement. Cout, L height, no longer garbage value. Now it has the value 6 in it. Now, as you noticed, CN will read the value once I hit enter. CN, as a matter of fact, will stop reading once it reaches a space character or an enter character. So again, CN will keep reading as long as it didn't encounter a space character or a new line character. Meaning, I can type as many numbers as I want. As long as it's within the range of integers, it's gonna read it and then display it. This is the maximum range of an int within this number. And it rounded it up because it overflew. We're gonna talk about overflow. Actually, it wrapped around its range. Just so I don't confuse you, I'm gonna run it again. And notice I'm gonna say 1, 2, 3, 4, 5. It's gonna read 1, 2, 3, 4, 5, and then it will encounter the enter character, and then it will stop reading. It's not one character at a time, not two, not three. It's as long as there are numbers without space character, without a new line character. Enter 1, 2, 3, 4, 5. If I run it again and I say 1, 2, 3 space 5, 6, 7, enter, notice it stopped reading when it encountered the space character. It encountered the space character, then it grabbed 1, 2, 3 from the buffer into the variable. 1 into the buffer, 2 into the buffer, 3 into the buffer. Oh, space character. Okay, stop reading, grab what's in the buffer, assign it to this variable, and move on. At this point, when I reach this line, the buffer has 5, 6, 7, but it's going to be lost because the computer ended. The program ended, sorry. So this is the CN object. Main rule is, or main thing to know, to remember, is the direction of the arrow. As a matter of fact, it's going to be a syntax error if you use the opposite. Another thing to know is when will the CN stop reading? So this was the CN object introductory. Then they mentioned entering multiple values on page 87. You can enter multiple values separated by space character. So I'm going to say int height, L width, enter your height, then your width. Enter your height, then your width. Cn into height, into width. I can do it in one line, reading multiple variables. Or I could have done it like the way I did earlier, but on two different lines. It really depends on your preference and the way you type. It's an art. At the end of the day, programming is an art. Every programmer is different. You can do it this way, or you can do it in one line. The rules apply the same. And the rules are keep reading until you encounter a space, or a new line. Once you encounter a space, grab what's in the buffer into the variable and continue. So F10, enter your height and your width. Here it is on the screen. Cn into height, width. Then I'm going to say 1, 2, 3, space, 4, 5, 6, enter. Now that I entered, no more characters in the buffer. It grabbed 1, 2, 3, separated by space, into height and then into width, respectively. That's from the book. A good thing to know is it doesn't matter how many spaces are entered between the numbers. So again, 1, 2, 3, space, 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 4, 5, 6. It's gonna ignore all the spaces. That's why you're gonna notice at some point that it's impossible to read space character using this operator, because this operator will ignore the spaces. So now that I did many spaces, 1, 2, 3 has been signed into height, then 4, 5, 6 into width. Then continuing with the book, mathematical expressions. They explain that C++ allows you to construct mathematical expressions, like complex mathematical expressions, using multiple operators at the same time. For example, let's start with the basic ones. For example, I'm going to read two variables using the CN that we just learned, and then apply some operation on them. So enter, for example, numerator L denominator. So enter numerator. Enter denominator. Then I'm gonna see out numerator over nominator. So start, let me remove the breakpoint. Numerator is 10, numerator is 5, then the result is 2. Notice, if I divide by 0, it's an error, runtime error. Good extra info is there are 3 types of errors in C++, or maybe in every programming language, every software development. You have 3 types of errors. You have syntax errors, you have runtime errors, logical errors. So you have, let's stop. You have syntax errors, you have runtime errors, then you have logical errors. Logical errors. Syntax errors means you didn't meet the rule, you didn't meet the grammar of the language. These are the easiest errors to solve or resolve. Why? Because the compiler is gonna point it to you. The compiler is gonna highlight, it's gonna draw red underline, and it's gonna tell you, hey, something is wrong here. You need to fix it before I can build. So syntax errors are the easiest to solve. Then you have runtime errors, just the one we saw earlier. Runtime error means the program, so syntax error, the program is not gonna build at all. Runtime error, the program builds, the program runs, and while it's running, it crashes. Something happens on runtime and it crashes. Then you have logical errors. Logical errors are the program builds, the program runs fine, it doesn't crash, but it produces wrong result. Instead of the car or the robot going left or the player in the game going left, it goes to right. It's supposed to go left, but it went right. As a student, I had that example in mind always about the rocket launching. So syntax error, the rocket is not going to launch in the first place. It's not going to turn on, it's not going to start its engine, it's dead. It can't launch, it can't start. Runtime errors is the rocket started, the engines are on, and it started launching, started climbing, and then halfway through the sky, something happens and it explodes. Logical errors are the rocket launches, engines are on, it goes through the sky, nothing happens, but instead of going to orbit X, it went to orbit Y. Instead of going to moon, it went to Mars. It's logical error. So what we encountered earlier, dividing by 0, that was a runtime error. The program builds, no syntax errors, it runs, then while it's running, something happens, it crashes. And in C++, when runtime errors occur, it's not just that method that fails. No, the entire software will crash, entire program will stop. In other programming languages, this method only will fail, but the rest of the program will keep running. So now you know about simple mathematical operation with the CN project. Then the book wants you to learn about operator precedence. Operator precedence means every group of operators have higher precedence than the other group, meaning group of operators must execute first, then the following group of operators. Just like we do in real life, when we have multiplication, addition, subtraction, we always, or actually we must do the division first, then we do subtraction and addition. We must compute or figure out, calculate these operations first, then we do the addition and subtraction. And as a matter of fact, negation is highest precedence. Once we do the negation, then we do multiplication or division or remainder. Finally, we add or subtract. Now, if we have an equation that has the same group, same precedence, then the execution is left to right. It starts by not left to right in this example, but left to right in the equation. For example, int my variable equal 1 multiply 2 divide 3 remainder 5 multiply 6. Let's say this is my equation. Since all the operators are of the same precedence, then the execution is left to right. So the multiplication of 1 and 2 first, then the result of this operation will be divided over 3. Then the result of this division will be remainder with 5, will be computed with 5. Then the result of this operation will be multiplied by 6. So if all of them are of the same precedence, the execution is left to right. Similar to this group, if I have all of them from the same precedence, then the execution is left to right. First, 1 plus 2, then the result will be subtracted by 3, then the result will be added to 5, then the result will be subtracted by 6. The final result will be assigned to my variable. If I have negation, then multiplication and remainder. So I have a mix of everything. In this case, I follow the order of precedence or precedence order. First, the negation. Okay, the negation happened. 1 became -1. Then multiplication and division and remainder. So 2 by 3 first, 5 remainder 6 second, because left to right. This operation will happen first, then this operation will happen first. Finally, the last precedence, which is multiplication and addition. Then left to right, negation 1 plus the result of the multiplication plus the result of the remainder. The result will be assigned to my variable. This is what the book is trying to tell you in this topic. Actually, what I forgot to say that you can break this rule by doing what you do in real life, parentheses. Let's say I want these to execute first, not multiplication, not remainder, but the addition. Then I surround it, I wrap it with the parentheses. Now that I have parentheses, then this is going to be executed first, then the negation, then the multiplication and remainder, and finally the addition. Then the book needs you to know about the power. The book thinks that a lot of programmers confuse power operator. For example, 10 power 2. They type it as 10 power 2, which is wrong. This is not the operator for power in C++. Maybe in real life, maybe in some notations in math, on the paper and pen, maybe some other programming language, but not in C++. This is the XOR operator. Don't worry about it now. The power operator is POW. You just say POW, and it's a function. If you covered functions before, POW takes 2 parameters. First one, second one. The first one, both arguments. Both are arguments, left and right. So 10 power 2. Then, what did we want to? Type conversion. The book wants you to learn about type conversion. It starts by saying when an operator's operands are different data types, means you are you're doing some mathematical operation on two different data types, like long and integer. So when an operator's operands are of different data types, C++ will automatically convert them to the same data type. This can affect the result of mathematical operations. So what's trying to say, every data, in brief, every data type has a rank, and there are ranks in the data types. The data type that can store a larger number has a higher rank. For example, what is the range of an int? Let's say the range of an int is -1000 to 1000. This is int. What is the range of unsigned int? Unsigned int is 0 to 2000. Long, from minus, for example, million to plus million. So the fact that unsigned int can store a larger number than int makes it higher rank. 2000 is greater than 1000. So since unsigned int can store a larger number than int, makes it a higher rank of int. And since long can store a higher number than both unsigned int and int, makes it higher rank than both of them. So the lowest rank in this example is an int. The highest rank is a long. If I do mathematical operation between int and long, C++ will automatically convert int to long. It will promote it to a higher rank. So there are rules for data type ranking, and this automatically convert, because there is nothing random. C++ will automatically, between double quotations, automatically convert. There are rules to that automatic conversion. Rule number one is characters, shorts, and unsigned shorts are automatically promoted to integers. Anytime you have mathematical operation using a character or short or unsigned shorts, they will become integers. First thing first. Then rule number two is, whenever there is an operator that works with two different values, then the lower ranking will be promoted to the higher ranking. The last rule is, when the final value of the expression is assigned to some variable, it's gonna be converted to the destination type. For example, I have an int equal sum my double plus al my char. So first rule is, any character, if I have character here, let's say char al my char equals a. Then I have double al my double equals 1.00006. So first rule is, any character or short or unsigned short must be promoted to an int automatically. So automatically C++, right when it reaches this line, it's gonna look, oh, I have a character promoted to an integer. This became an integer. Then rule number two, if I have two different data types, then the lower ranking should be promoted to the higher ranking. This became an int. Int and double are different. Int is lower rank than a double because double can store a larger number, then convert this part and promoted to the higher level. Now they became both double. Do the math expression, then the result will be assigned to my variable as an int. So the rule number three is, convert the result to the same data type where we are going to assign it. So when the final value of an expression is assigned to a variable, it will be converted to the data type of that variable. This is what the book is trying to tell you in 3.3. Then 3.4 speaks about overflow and underflow. Basically, when a variable is assigned a value that's too large or too small, then too large or too small to that variable's data type. Remember, every data type has a range, and these are just example. If I want to put 2000 in an int in this example, if I want to put the value 2000 in an int, overflow will occur. If I try to put minus 2000 into an int, underflow will occur. And underflow and overflow basically will wrap around the range. So quick example, just so you can understand it. I'm going to go to Paint. Let's say the range is 10 or minus 10 in this case to 10. This is the range for some variable. If I assign 11 to that variable, then the variable is going to carry minus 9. It's going to round around its range. If I say my var, that is of that data type, equals 11, semicolon, then I run my program and I hover my mouse on my var, I'm going to find minus 9. If I say 13, then I'm going to find it's minus 7. Minus 7. So this, in this case, it's an overflow. I gave it a number that is larger than its range, so it's trapped around its range, became minus 7. That was the overflow. Underflow is assigning it. Underflow is assigning it a number less than its minimum. So let's say I say this number is equals minus 15. Once this statement executes, I'm going to find that my variable is carrying 5. That's what overflow and underflow are. Then the book speaks about 3.6, topic 3.6, multiple assignment and combined assignment. Multiple assignment is basically using one value to assign to multiple at the same time. For example, I'm going to say I have an int lvar1, lvar2, lvar3. Then I can say lvar1 equals lvar2 equals lvar3 equals 10. This is multiple assignment. 10, it's from right to left. 10 is going to be assigned to var3, then var3 will be assigned to var2, then var2 will be assigned to var1. That's basically it. Then they want you to learn about combined assignment. Combined assignment is doing something like this. If you remember, well, let's assume you don't know, but I can do something like this. lvar1 plus 10. What will this statement, let me remove this just so I don't confuse you. So I declared variable called variable1. Then I assigned a value to this variable. I said this variable now carries 10, or the value of this variable is now 10. Then I said this variable equals to this variable plus 10. What's going to happen is I'm going to end up with 20 because var1 is carrying 10. I added 10 to it. The result is 20. Then 20 is going to be assigned to the left side of the assignment operator, the equal operator. So now I have 10. This is a way. Another way is, or another syntax is doing it like this. And this is combined assignment. Plus equals 10. This statement is equivalent to this statement. It does the same exact thing. Alvar equals alvar plus 1 plus 10. Alvar plus equals 10 means whatever the value is alvar 1 plus 10, I will end up with 20. So notice, I'm going to see out alvar at this point. And I'm gonna comment, well, I don't have to comment it, but notice it's gonna display 20 on the screen. 20. Why? Because alvar is 10, 10 plus 10 is 20. I'm gonna replace it now with this, and it's gonna behave the same, 20. This is called combined assignment, and combined assignment is not just addition. You can do it with subtraction, now it becomes 0. You can do it with multiplication, now it becomes 100. And you can do it with division. Now it becomes 1. Or you can do it with remainder as well, becomes 0. Okay, here it is. So that's combined assignments. Then the book wants you to learn about formatting the output. Formatting the output, let me take off these. And the book does what? Is the book in program 3-12 is declaring some variables with values and then displaying them randomly. Okay, so formatting output. We're gonna learn, or you saw already, that the cout object provides one way, like no default way for displaying, right? I just say alvar1, I can do them in one line. alvar2, alvar3. And let's say I have some other variables of 4, 5, 6, 7, 8, 9. And for the sake of demonstrating, I'm gonna give this 1, 2, 3. We'll give this 4, 5, 6, 7, 8, 9. As a matter of fact, I'm gonna give it 2, 2, 2, 3, 3, 3. Then I'm gonna give it 4, 4, 4, 5, 5, 6. Just some random pattern. Then 7, 7, 8, 8, 8, and finally 9, 9. So I'm displaying, what is it? Annoyed? Okay, it's not annoyed. Boom, boom. So var2, actually 2, 3, var4, var5, var6, var7, var8, var9. And let's give it end line. And L. Now display. Unfortunately, well, I didn't give it spaces, so let's give it spaces. Space, 1 space is enough. Copy, paste, copy, paste, paste, paste. Run. So notice how the numbers are like, they don't line up in columns. Like this 4 right here. Actually, let me edit properties. Let's font. Let's make it bigger for you. Yeah, this is much better. Yep. So as well, before returning, cout and L and L and L. This way we only see the data we care about. What did we do wrong? Cout and L and L and L, L, L. So this way we only see, yep, the numbers we care about. So back to this, notice we don't like how they are displayed. This 4 is below this 2. I would like to see them in one column at a time, perfect square, let's say. So this is the default behavior of a cout statement. But C++ provide us with a library called input-output manipulators. So include input-output manipulators. This provides me with maybe 5 or 6 stuff. Provide me with set W, set precision, fixed, show point left, right. Set precision fixed, show point left, right. Maybe it's one more, but I remember it on the way. So set width. Set W means set width. If I grab this bad boy and I say to see out, hey, see out, you see, so see out, this operator, then I give it 5. What I'm basically telling it, hey, see out, you see the variable I'm about to display, I needed to consume or to allocate 5 characters on the screen. Then I do the same. Hey, see out, you see the variable I'm about to display, I needed to have width equal to 5. Same. So if I go ahead and do the same for these two, now notice on the screen, actually, I'm gonna give you a better idea by doing some dashes on the screen. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So this is the first line. Now notice that this number that I displayed here, var1 equals to 1, it consumed 5 characters on the screen. So the width of this number is 5. Then the width of this number is also 5. 1, 2, 3, 4, 5. Then the width of this number is also 5. 1, 2, 3, well, from here. 1, 2, 3, 4, 5. Same case. So now they look nicer. Everything is lined up. So it's easier for the eyes, for the user. This way has better user experience. The user is going to be happy, or at least happier with the result. Now notice the alignment of the number is right of the width. So by default, if I don't tell see out anything, it's going to put the number to the right side of the width. The width is 5, but the one is on the right. Why the one is not on the left? Because I didn't tell it. If I go ahead and I tell it, I want you to set width 5 and align it left, then notice that the numbers are going to be aligned to the left. So by default, it's to the right. So notice now, the width is still 5, but it's aligned left. Also the same case for this. It's still 5, but aligned left. So if I start from here, 1, 2, 3, 4, 5. Well, maybe from this one, 1, 2, 3, 4, 5. Then it's right here. So makes sense. 1, 2, 3, 4. Well, 1, 2, 3, 4, 5. So anyway, you get the idea. These are aligned left. As a matter of fact, all of them. Oh, okay, so maybe I need it only once. Boom, boom, boom. Oh, I see. Sweet. So only once. Once I tell see out align left, then it's gonna align everything left up until the end or the new see out, or maybe up until I tell it actually to be right. So now it's left aligned. So you saw so far set width left and right. Right is right, but it's default. So I can tell this to be left. I can tell the following one to be right. Then I can tell the following one to be left again. So notice this is left aligned. This is right aligned. This is under the 5. This is left aligned again. So far we saw set width, left and right. We still have set precision, fixed, and show point. Set precision is for the decimal number. So I'm gonna format my output to display, for example, only 3 numbers after the point decimal, or 5 or 10. So let's do some examples. Let's remove these and let me say that this is 1, 2, 3, 4, 5. Actually, I want it to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and this has 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I'm gonna grab only var1 because that's what I care about right now. Then I'm gonna tell it to display. Let's see what it displays by default. So by default it is because it's an int. So I'll tell it it's a double. Notice it truncated the decimal because it was double. I gave a floating point to an integer, so I lost the decimal. So now I fixed it by telling it I need this type to be double display. The default behavior is exponential because it's too big. So if I reduce it to 5, then it's going to display it as is, I believe. Oh, okay. So this is the default one decimal after the point. So I can control that. I can control that by doing, we don't need this line anymore. I can control that by using set precision. So as you noticed, it's only one number after the point. I'm going to tell it, hey, set width to 3, for example. Now display. It's a little too big, so let's reduce it for the example. Set precision to 5 because it is 5 numbers. Then it's going to display it as is. So here it is as is, 5 numbers, 2, 3, 4, 5. I can go back to the big one. So this is set precision. How many numbers do you want to see? I can show fixed. Fixed means show it as is. Do not change the notation. So fixed. Set precision, well, we don't need it anymore. Notice without fixed, it's going to display as notation because it's a little big, or maybe it's going to lose that 6, 7, 8. Where is the notation? Give me, here is the notation. So now I can tell it I want it fixed. It shows it as is. Also, show point will show me the point. So at this example, it's going to do the same thing. Oh, it didn't. Okay. Show point was to fixed is to fix all the undesirable behavior. You have one way and then you try to display it and it shows different behavior that you expect. Fixed means do exactly what I'm telling you. If this number is this, do it as is. But show point was show point was to dump to show 0, I think. So if I say I have 12, right, 1.12, and I tell it set precision to 10, for example, and show point, then it's gonna add zeros up until the 10. Here it is. Yep. So that was show point. So you saw all of them: set width, set precision, fixed, show point, left and right. Save and move on to the next topic. Actually, there is a cause a decimal point in training 0 to be displayed even if there is no fractional part. Okay, so table 3-12 shows all 5, all 6, and a description about them. Then the next topic is 3.8, working with characters and string objects. This topic is trying to tell you that there are special functions that exist already from the language, provided by the language, that help you work with characters and string objects. For example, remember when we said CN impossible to read a space. So let's say I have my character and it's empty for now. I can't, okay, it's A for now. Then I say C out, enter your character. CN into L, my character. Now if I run, I hit space, it's not gonna read it. Hit space again, it's not gonna read it. Space, 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 space. So what if I actually need the space? I want the space. Let's say it's part of a password and space is considered in a password. Then I need to use a different operator. As a matter of fact, it's gonna be a different function. Get into my char. This get will read one character from the screen into my variable, only one character, whatever that character is. So if I say space, enter, oh, let me stop to show you. So if I say space, enter, now my char is the character space. Space in the ASCII code is 32. So if I go to ASCII code again, example this image, and I go to 32 space character. So one of the methods that help me is the get one space exactly. Another one that is helpful is when working with strings. So there is a library called string. And let's say I have a string that is empty for now. So L my string. Enter your full name. Then I'm gonna say, okay, CN into L full name or L string. L my string. And then I'm gonna stop here, or I don't need to stop, we can display it. Display what we see. L my string and L. So run. Enter your full name. My full name is this. Boom. But CN, as we learned, will stop reading when it encounters a space character. So how can I grab the entire data or the entire buffer or the entire string and put it in one variable? Then I can't use this operator and I must use a different operator. And that different operator is a method called getLine. GetLine from to. So it takes two arguments. The first one is from where, and the second argument is to where. So from the CN into my string. Now when I run again, what's my full name? This is my full name. Boom. The entire string, the entire line. So everything, including spaces up until the new line character, was read and assigned into my string. What else? Also, there is CN ignore. So just so how you saw CN.get takes only one character, then you have CN ignore one character from the screen. Sometimes you get into issues when you are working with console application that the system, for example, maybe we saw it in part one when I ran the program and it was waiting for me to enter a key for it to execute. So sometimes you have some undesirable behavior where the screen is just waiting, the buffer is not empty yet. So it's usually fixed by saying CN ignore. For example, you call the function twice and it will empty the buffer and the program will continue executing. Also here it tells you that the string has some important methods that are built in. For example, it can tell you without you counting, like micro programming and counting the character. It has a method called length that will tell you the length of that string. So run, what is my full name? This is my full name, and it's gonna display 13 for the length. I didn't have to iterate character by character and count. It's just provided by the language. Another thing is, for example, let's say I have my string 2 equals hello. I can as well do addition, my string 2, and that will display the addition. So it added hello at the end of the string. So concatenate, and it happens like you see it. My string concatenate to this string. Then they go to random numbers, random number generation, which is topic. Oh, we're still under the same topic. Interesting. So random numbers. Why do we need random numbers? Random numbers are very important in general computer science, whether you are building a game to roll a dice or to shuffle a deck or to grab a random card from a shuffled deck, or like if you play PUBG or Fortnite or Warzone, you know how even from the beginning of the game until the end, at the beginning of the game, the matcher is gonna pick 100 players randomly, right, and put them on one plane. Then the plane is gonna cross the map in a random fashion. One round, it's gonna cross from north to south. Another round, it would cross left to right, diagonal. And then you're gonna drop to a house and you're gonna find a random box in a random room that has random items in it. Then you're gonna play until the gas comes. Once the gas comes to the first circle, then a smaller circle will randomly be located on the map, and then the gas is gonna come and you have to run from the gas into the circle. Once the gas reaches the border of the circle, then a new random circle will be generated, and so on and so forth. So everything is pretty random. Also in simulated programming, sometimes you build a program and you want random simulated data. You want to simulate some antenna transmitting or some, let's say, some human is pressing on the gas pedal in the car and you're working with the RPM or the speedometer. If you're working on the software of the RPM and the speedometer, you can simulate the gas pedal. You can just create a random program that simulates someone pressing on the gas pedal, and that random program is gonna send you, okay, the pedal now at 10 degree angle, 12 degree angle, 15, 90 degree, etc. Well, I doubt it's 90, maybe maximum is 30, 0 to 30. So it's important in simulated programs. It's important in statistical programs where you have a lot of data and you want to grab a random sample. And security and encryption. So there's a lot of usage for random number generation. So how do I get a random number? It's provided by the language int l my rand equals rand cout l my rand. The problem with this, let me do it again. So boom, boom, para. Then cout again. Copy, paste, paste, paste. So I'm calling random 5 times. 1, 2, 3, 4, 5. I'm gonna run my program. Notice This time I have this list of random numbers. I'm gonna run it again. Oh, well, too bad. Same, close, close. Same list of numbers, 41, 634, same list. Okay, let me try again. Boom. Oh, well, same again. So that's not random. I'm getting the same list over and over again. And that's how the generator works under the hood. The rand generator under the hood has static numbers. Static numbers, then some mathematical equation that produces the final number and assigns it to my rand. If I don't do anything, I'm gonna always get the same static numbers because they are stored in the database like actual numbers. Let me explain really quick how it works. This rand function has list of numbers in its database, static. Well, that was terrible, but bear with me. It has, let's say, 3, 15, 19, 20. Some random numbers stored already. And it has a static variable that is 1, starting with 1. When you call it, this method will grab X, will add the first slot, in this case 3, or maybe multiply it just to make it simpler, multiply it with the first slot and send it to the user. So what's the result? First slot is 3, here is the 3, X is 1, here is the 1, the result is 3. On the next time over, the next time someone calls this function, this has been consumed. Then it goes to the next one into the same equation. X multiplied by 15, sent to the user received 15. So the fact that these are static in the database, every time I run my program, it's gonna start from top to bottom. First, it's gonna return 3 multiplied by 1, 3. Then 15 multiplied by 1, then 19. I shut down my program. I start over. It's gonna start over from top. So every time I rerun my program, I'm gonna get the same series, unless I change this variable. If I have control, or if I can trigger a change to this number, then every time I run my program, I'm gonna get different results. Why? Because 3 multiplied by different number is gonna be something different than the previous result. Also, to be more secure, the best way to assign this variable is guaranteeing that it's unique from the previous execution, and not just the previous execution, any previous execution, not just the first, not just the one right before it. And the best way to do this is to use time, because the execution time is always unique. There is no way I can execute twice in the same exact microsecond. So this comes to the topic of seeding my generator. And if I seed my generator using time, then I'm guaranteeing in a perfect fashion that the series of numbers are unique from any execution, because the time of previous executions was different than the time of this execution. And the way you do that is you call a function called static rand, and then you give it time with null. Now that I seeded my generator, all these calls will provide different series. At one execution, I'm going to see different series. On the next execution, I'm going to see different series, and so on and so forth. So this execution, I have these numbers. I'm going to restart now. This execution, notice, no duplicates. This was one way. This is a different way. Unique random numbers. If I try again, it's going to happen over and over. This these numbers are different than the previous execution and also the first execution. Now I have 3 executions. 4. This execution is different than the 3 and third time and second time and the first time. So this is very important. You must seed your generator. So this is everything about random number generator, what the book is trying to show you. Then we move to next topic. Oh, this is it. Chapter 3, done. Cool. Chapter 4, making decisions. They start with relational operators. Relational operators. You have 4 relational operators, maybe 5. Let's see. So you have greater than, less than, greater than or equal, less than or equal, and not equal. Yeah. So they are called relational operators. That's how I remembered it as a student. They are called relational operators because it's trying to figure out what is the relation between the left to the right. Is it greater than? Is it less than? Is it not equal? Is it equal? So we have 6. Relational operators try to figure out what is the relation between the left operand to the right operand. If it's greater than, then it returns a Boolean. It always actually returns a Boolean, but if it's greater than, then it returns true. If it's not, then it returns false. Is it greater than or equal? Is it not equal or is it equal? And be very careful. The equal operator is the equality operator and not the assignment operator. You have my var equals 1 plus 2. This is the assignment operator. This is the equality operator. Do not mix and match or confuse. This is for equality, checking if equality, and it will return a bool. This is an assignment operator, grabs the value on the right and assigns it to the value to the left. So relational operators allow you to compare numeric and character values and determine whether one is greater than, less than, equal, or not equal to another. And you have table 4.1 that lists them. And don't confuse equality with assignment. Then we go to the if statement. An if statement can cause other statements or other code to whether execute or not. Only under certain conditions they will execute. Otherwise, it's not going to execute. For example, let's say I have a test, and if the grade is above 60, you pass. Otherwise, you lose. So int L my grade equals 70 for now. Then the if statement has this format. It has if expression statement. So if, what's my expression? My expression is whether that grade is greater than or equal to the passing grade. So here I'm gonna have a const int called passing grade equals 60. Then I'm gonna ask the user what's the grade or receive it from somewhere on the network. What's the grade? 70. Then I'm gonna go to my if statement. If L my grade is greater than or equal to passing grade, and notice it's like storytelling from left to right. Then see out you passed, or congratulations. Congratulations. Otherwise, do nothing. So now I run with F10, stepping through the code. Go. My grade is 70. Passing grade is 60. If my grade is greater than or equal 60, then execute congratulations. F10. Here it is, congratulations. Now, let's say it's 50. Run again with F10. My grade. Is my grade greater than or equal passing grade? No, it's not. So this operation will return false. Then if false means do nothing. Boom, it didn't display congratulations. So a statement executes only if the conditions have been met or the expression has been met. That's the if statement. The if statement in a design fashion, you need to know these two. So let's draw them. A flow chart, and a flow chart, which is one way of writing a program on a piece of paper or an algorithm. You have square, or more like curved square. This indicates start, end of a program. You might be asked, I might provide you with a flow chart in the exam and ask you to write the program, or I might ask you to draw the flow chart. I provide you with the program and ask you to draw the flow chart. Let's go to 28. This shape indicates start or end of a program. Then you have this shape, diamond, that indicates decision making, which is an if statement. Decision making. I remember there was a flow chart in this book, maybe in the homework section. This is it's not there. Change. Yeah, anyway, back to flowchart. Okay, so decision making, this shape is decision making, and usually you see it something like this. You see the flow coming, and then you see a diamond. Then you have a yes, no. Yes, do something, no, do something else. Then you have this parallelogram. Do we have it here? We don't have it, okay. We can draw it. Parallelogram indicates output and input. Does it look like a parallelogram? Maybe not. This indicates input, output. Then finally, you have the square, just a regular square or a rectangle. This is more like oval. So square or a rectangle, this or this. A rectangle is a square actually. But square is a rectangle with equal sides. So this means processing. Some processing is occurring. So let's fix this to a more oval place. Yeah, like a little bit oval. You're gonna notice the difference. It's oval shape. So these are what you need to know. If I provide you a flow chart that looks like page 176, you must be able to write the program. And if I give you a program, you must be able to convert it to a flow chart. So don't save. Back to the book. Where were we? Yeah, don't confuse equality with the assignment. We did that. Expanding the if statement. So expanding the if statement means having more than one statement. If this is the case, do many things. In order to do many things, I have to provide it with a body. So remove this, give it a body, open curly braces, close curly braces. Then I want to see out, congratulations, see out again, you passed, see out again, way to go. I can do whatever I want. It's a block. I can do math. I can call other functions. I can do big process, small process, complex computation, whatever I want. So run. It's not going to display anything because the condition didn't meet. 50 is less than 60. So let's put it as 60. Hey, is 60 greater than or equal to 60? Yes. Congratulations. You passed. Way to go. So I expanded the if statement. Then they introduce the if else statement. So if this is the case, do this, else do that. So if this is the case, congratulations, you won or you passed. Else, see out, sorry, you failed. Hmm? How come you can't? Oh, here. Okay, so if else, I'm gonna put a breakpoint, run. If 60 is greater than or equal 60, notice it's gonna ignore the else part. It didn't execute the else part. However, if I say my grade is 50 and I run again, what's the expression? Is 50 greater than or equal to 60? No, it's not. Then it will execute the else block. Sorry, you failed. Sorry, you failed. So that's basically else part of an if statement. Then we move on to nested if. Nested if having an if inside an if. So if my grade is greater than the passing grade, another if, some other condition, again, I can have as many as I want. If this is the case, also if this is the case, also if this is the case, then execute. I can also have the else statements here. I'm trying to move quicker on these topics because they are relatively easy and I don't want to waste your time. So if you have questions about these specific, relatively easy topics, let me know. Then they move to logical operators. I'm going to remove all these and go with logical operators. You have and operator, you have or operator, and you have the not operator. Not. So and or not, very simple. This will return a true or false based on two booleans. So you're gonna have two booleans or two expressions, and then you're gonna AND them together to produce one boolean. You're gonna OR them together to produce one boolean, or you're gonna not or check negation, but basically check if something is not what it is. So let's start with the AND. I'm going to open the paint again because it makes more sense if we visualize it. Again, I'm going to have something like this. you're going to have a code that says if some expression and, well, that's an 8. So let's do it like this. And, then do something. Comment. So you're going to have an expression that produces some bool, right? Remember the expressions? If this is greater than that, or this is equal to that, or if this is not equal to that. So you have some Boolean here, some other Boolean here, and then you add them together to check if this is Boolean and this Boolean both are true, then do something. This is how the AND operator works. So what are the possibilities for this bool? This on the left side can be either true or false. Only two, right? Remember the Boolean has only two values, either 0 or 1, either true or false. Also, I have 2 on the right side. The possibilities are 2. Possibilities are 2 here, possibilities are 2 here. So how many combinations I have? I have 4. I have either this one is true and this one is false, or true, true, or false, true, or false, false. So I have 4 cases, 4 possible cases. So let's do it like this, and then like this, and then like this. 1, 2, 3, 4. So black. So I have what first case is the left is true, the right is false. Second case is both of them are true. Then I have either false, true, false, false. So it's an AND operator. Imagine saying, if you have a car and gas, then you can go. If you have a car and gas, so in order to go, you must have both car and gas. So the only way this is possible, the only case it's possible is when both of them is true. So true and true is always true. True and false is false, meaning I have a car but I don't have gas, then you can't go. The result is false. If both of them are true, then the result is true. If I don't have car but I have a gas, I can't go. If I don't have a car and I don't have a gas, then I can't go. So in an AND operator, the only possible case where the result is true is when both of them is true. When both of them is true, then the result is true. This evaluates to true, then the if statement executes. That's for the AND. Now we go to the OR. I go to the OR. And with the OR, I'm going to also have the same cases. In the OR, I have two sides. Both of them are Boolean, and I'm trying to OR them together. If I want to simplify the example, I can type if you have a car or a bicycle. Bicycle, then you can go. So for this to be true, for this to be satisfied, in order to go, I either need a car or a bicycle. So if one of them is true, the whole statement is true. I have a car, but I don't have a bicycle. Can I go? Yes, you can go. I have a car and I have a bicycle. Can I go? Yes, you can go. I don't have a car, but I have a bicycle. Yes, you can go. I don't have a bicycle, I don't have a car, then you cannot go. So if you noticed in the end, the only case where the statement evaluates to true is when both of them is true. On the other hand, with the or, it's always true, except the case where both of them is false. If both of them are false, then the entire statement evaluates to false. So this is the and, this is the or, and then you have the final one, which is not. And not is like this. Not. So basically not has only one bool. If not bool. So let's say this bool variable called, for example, bool L is connected, right? And I'm gonna give it true for now. Then if not connected, oh, see out, not connected. So L is connected has a true. I received some transmit, some radio signal that it is connected. Then I'm checking, hey, if is connected is not true. If not connected, notice how the variable naming helps. If you pick proper variable name, you make it much easier for you to solve your own code or others to read your own code. So if not connected, then it's not connected. Is this true? No, it's not going to execute because connected. The if statement says if not connected. If not connected. Now, let's say is connected is false. The variable is connected is carrying false. So what is the opposite of false? True. That means it will execute. So if not is connected, if not in this case, since this is false, if not false, so what's the opposite of false? True. Means the entire statement will evaluate to true, means the entire if statement will execute. So if not connected, or if not is connected, then execute not connected. So that was the and, or, and not logical operator. And they are called logical operator because they are pure logic. If you follow this example, it's pure logic. If you have a car or a bicycle, then you can go. The only case you can go, or the only case you can't go, is when you don't have a car nor a bicycle. Then the book needs you to learn about, this is easy, comparing character and string. It's telling you can use relational operators with strings and characters. Needs you to know about conditional operators. And we will stop at conditional operators. Actually, let me see. Yeah, we will stop at conditional operator because I don't see the time. Maybe we are over time. Teams is not telling me how long I've been recording. I should have paid more attention to the time. Anyway, the conditional operator. The conditional operator is a simple, quick if statement. So I'm going to remove these because we are done. Conditional operator is something like this. For example, my var int my var equals some expression. If true, else if false. Something like that. So my variable equals expression means expression means something evaluates to bool, right? It's expression, whether it's a relational expression or an and or an or, something at the end of the day evaluates to a Boolean, either true or false. This expression is going to be either true or false. Well, that's too much. Let's do it like this. Okay. So if this expression evaluates to true, then this section between the question mark and the colon will execute. If this expression evaluates to false, then this part will execute, the part between the colon and the semicolon. For example, let's say, back to the grade, int L my grade equals 50. And the passing grade is const int passing underscore grade equal 60. My expression is, or let's say the string L result, right? The string L result is equals the expression L my grade greater than or equal passing grade. If this is true, then assign passed to my string. Otherwise, assign failed to my string semicolon. I can put it in a new line. So when this statement executes, the fact that my grade is actually less than the passing grade, then this will evaluate to false, then this section will execute, meaning it will grab this value and assign it to result. If I change it so that it evaluates to true, then this section will be grabbed and assigned to result. L result. So notice, result is failed because this evaluated to false. Failed. If I change it to 70, then this expression will evaluate to true. Yes, my grade is greater than or equal passing grade, then this will execute. Boom, passed. And I'm using the word execute because you can put anything you want here. Here, you can put anything you want. For example, I can cout passed. Or maybe not, because I'm using assignment. So let's do this. Cout and L, and here cout failed. I'm pretty sure it will work. So let's take these off. Yep. So this is the expression. I don't have to do anything. I'm just executing. This is the expression. If it's true, execute this, else execute that. So run, go. What did it display? Passed. Cout passed. And I'm gonna stop here because I don't know the time. I'm gonna work on having a timer in front of me next time. And we only need switch from this topic. So I'm gonna do it at the beginning of the next session. I'm gonna plan to post it tomorrow. This way we cover 4 hours in this week. I prefer that I post it on Wednesday. This way we mimic a real situation where we have a class on Monday and then another class on Wednesday, so that you don't get overwhelmed with 4 hours in one day or 2 days, Monday, Tuesday. So I will try tomorrow. I can plan for tomorrow, but we'll see throughout the semester if it's better to have it all in one day, or Monday, Tuesday, or Monday, Wednesday, maybe Monday, Friday. We'll see. For now, this is it. I'm gonna go ahead and post the homeworks and let me know if you have any questions.